Hello, everyone. Good evening, and welcome to CocoaHeads for April 2021, which I believe marks a full year of doing these remotely online. I'll have a bit more to say on that later as well. But to begin with, I would like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of the land on which CocoaHeads normally gathers in the CBD, and I pay my respects to the elders, both past and present. Straight into a bit of housekeeping. Your hosts. Hi, I'm Zach. We've also got Nikki who helps us out with CocoaHeads, but he unfortunately can't join this evening. And Carl is on the call. So, hey, Carl.
Hi, everybody. Welcome to CocoaHeads.
Thanks, Carl. As always, a big thank you to our sponsors, Billu and Atlassian, who help make our events possible. A reminder, as always, that CocoaHeads has a code of conduct, and we want everyone to feel welcome and comfortable at our meetups, be it online or in person. The code of conduct boils down to 3 key points: be respectful, be inclusive, and be aware, and can be read in full on the website at that link there. If there are any issues with the code of conduct, or if you'd like to report anything, please do so to myself, Carl, or Nikki, and we take those all very seriously. A reminder that CocoaHeads has a Slack community, so everyone's welcome to join. It is, of course, subject to our code of conduct, but it's sort of the place where discussions are happening during these remote meetups, especially, as well as during the month. There's often posts in there about various things related to iOS development. So feel free to join, take a screenshot of the screen if you'd like now, note that URL down, and feel free to join in tonight's discussion. As always, a big welcome to first-time attendees and anyone who might be joining us from outside of Sydney, thanks to the magic of the internet. So straight into some other events that you should keep an eye out for. The first is Melbourne CocoaHeads. They are very similar to us in that they run in a similar format. They run on the second Thursday of the month. We run on the third. But if you like what you hear tonight, the format of a couple of talks and some light discussion at the end, they also do a similar thing. So definitely recommend checking them out. Some other events to keep an eye out for. We've got invites to an Apple event that's happening next week on the 21st of April at 3 in the morning in Sydney anyway. A few things expected there, all the latest Apple products, iPad Pros, potentially new Apple Silicon Macs, maybe an iMac, who knows, maybe an Apple TV, AirTags, all those things that have been rumored. So it'll be interesting to follow along with the announcements next week. And the other thing that's happened in the last month is Wwdc has been announced. So it's happening online again, no big surprises there. It'll be June 7th to 11th or 8th to the 12th if you're in Australia. And we currently have almost no other details. So we'll have to stay tuned, I guess, over the next couple of months to see exactly what's happening there. But I'd say it's safe to assume it's going to be run pretty similarly to last year. Also worth calling out regarding Wwdc is the Swift Student Challenge. So it's an opportunity for anyone enrolled in education course. I don't think it's just limited to university. You can apply for a Swift Student Challenge, and it's kind of a prestigious award that Apple give, I think, to 350 students from around the world. And the challenge is to create a Swift playground. And in return, Apple, if you're successful, Apple give you some WWDC goodies, and it's a pretty prestigious award as well if you're a student. So definitely worth checking that out if you're interested. All right, so on to hiring and firing. If you are looking for work, or if you have a role to fill, the best way to get in touch with your people would be in the jobs channel on the Slack group. We did have a post in there earlier today that mentioned that Afterpay is hiring in Sydney. I believe it could also be in Melbourne. So check out the jobs channel if you're at all interested in that. And on to tonight's schedule. So our first talk is from Terry from Originware. Very much looking forward to that. And we have a second talk from Tom from Bare Feetwear. So looking forward to both of those talks, and thanks to both of those presenters. And then following the second talk, there'll be a post-Zoom catch-up. I'll post the meetup in the Slack group at the conclusion of the meetup. So hope to see as many of you there as possible. On to something a little bit exciting, May CocoaHeads. We're still looking for talks, or lightning talks, or a month in review. Anyone's welcome. Please feel free to get in touch if you'd like to workshop an idea, or if you have an idea for a talk that you'd like to give. I'm happy to talk through that idea. But the big news here is that we might be back in person. Obviously, this depends on a few things, including the COVID situation in a month's time. So it could go back to online basically in really short notice. But the plan as it stands at the moment is to aim for an in-person meetup. So we'll be posting details about location and things like that as soon as we have them. But the best place to stay tuned for that information is the Slack group, as well as Meetup. And I'll also be posting it on Twitter as well. And we will do our very best to live stream the event for those who can't make it. So any venues that we're looking at the moment, one of the requirements is live streaming. So hopefully, fingers crossed, that works well if we are meeting in person. So I'm very excited for that, and I hope to see as many of you there as is possible. All right, let's get straight into the first talk from Terry. So I'll start playing that now. And I believe Terry is in the Slack group tonight as well. So if you've got any questions as we go, this is a pre-recorded talk, so feel free to ask them in the Slack group as we go.
Welcome to the OriginWare.com presentation on semantic transcription. And may well you be asking, what is semantic transcription? Well, the term semantic refers to the meaning of sentence text, but meaning in a structured and formalized sense in the same way the grammar is structured and formalized. Let me explain semantic transcription to you this way. I take it as a matter of course that you were educated with a grasp of grammar, but at the same time I take it you were not educated with an understanding of the meaning structures that belie sentence and sentence text. I take it that you were left to your own devices to build up those mechanisms and mappings you needed between words and text and their meaning, and that was an unconscious process for you. It became an active unconscious process for you, a process you're possibly using right now, but at a conscious level.
Sorry, my bad. I was just trying to get rid of that annoying progress bar at the bottom.
Welcome to the
a little bit.
Words and text and their meaning, and that was an unconscious process for you. It became an active unconscious process for you, a process you're possibly using right now, but at a conscious level you're completely unaware of those meaning structures there and how you interpret them. Maybe a better way of describing it is, imagine the scenario where you weren't taught formal grammar. So you learn conversation through conversation with conversation, and then at school you were supported in reading and writing and reading books. And so you built up an unconscious mechanism of understanding words and word arrangements and word representation and how they map to some form of meaning. But if I tried to elevate that unconscious process that you had to a conscious level, and I asked you about phrases and clauses and the role of prepositions, for example, in the sentence and word scheme, you would only be able to expound on those in very, very vague levels. So I presume that this is your standing with semantic and semantics. You have an unconscious active process that you use to interpret that. But at the conscious level, you are completely unaware of the meaning structures and how you interpret them. So a formal definition of semantic transcription is the mapping of sentence and sentence text to its structured meaning. You may have a follow-on question as to what would semantic transcription be used for. Well, it has direct application in traditional vocal system control, but more generally those systems that engage in vocal interaction. So that encompasses knowledge domain systems, which are vocally active, vocal control of apps, IoT devices, instruments, medical devices, appliances, toys, games, and so forth. So from this presentation, you should come away with a conscious, and I'm using a keyword conscious here, a conscious appreciation of the meaning structures that are there within sentence and sentence text. If you actively develop vocally active systems, their meaning representation is certainly going to be of interest to you. If you actively work with IoT devices, Then there is, in part 2, an IoT demonstration where I show semantic transcription running on to IoT class devices, and that will certainly be of value to you. I also want to touch on the visual elements you'll be seeing in this presentation. So this video is put together with the OBS broadcasting package, and currently there is a webcam on me with the background being an iPad with the slide source. So there'll be a number of video sources I'll be using. I'll be annotating the slides with a pen on the iPad, and then additionally there'll be a desktop source where I'll be demonstrating a vocally active app that I'll be vocally engaging with, and that app will be giving you visual cues as to when it is listening, so you understand when I'm conversing to you and when I'm addressing that app. Additionally, there'll be a camera on some Raspberry Pi devices during the IoT demonstration in part 2. I'm actually going to transition myself out of view now. That is because I'm going to have my head down. I'm going to be working on the iPad, annotating the slides, switching between OBS views and engaging with that vocal demonstration app. So you'll hear me in the background. You'll both hear and see the demonstration app vocally engaging. You'll see slides and so forth, and hopefully you'll understand what is going on. I want to introduce you to the vocal demonstration app. So let's switch to the desktop view and do some introductions. Computer, identify yourself.
I am Timetable Agent, version 0.9, running on Mac OS. My aliases are Computer and Cyano.
Please introduce yourself to the audience.
Hello everyone, I am Timetable Agent, your assistant. I demonstrate semantic transcription technology from originware.com. This technology transcribes the text of spoken queries to their essential meaning. It allows applications to comprehend the intent of directed textual requests and so synthesize relevant replies and actions. Please just ask, and I can respond to your vocal requests.
Okay, so would you like to give the presentation?
Sorry, it is not my function to give the presentation.
Well, that reply was not contrived or specifically sculptured for the question. Rather, it was a natural functional product of the way the transcription SDK operates. The same if I had have asked, can you teach me to play the piano?
Sorry, it is not my function to teach the piano.
Computer, why are you here?
Sorry, I don't know why I am here.
These responses were auto-generated. The system transcribed the first question, can you teach me to play the piano, as a polar question, and the second, computer, why are you here, as an interrogative question. Then a negative statement semantic was generated from the original semantic with pronouns inverted, for example, you was inverted to I, and auxiliary verbs, such as the verb to be are, were positionally transposed. This particular instance has specific knowledge domain related to train timetabling. In fact, it actually contains an internal train timetable simulator for the Greater Sydney region. Computer, what is your function?
I know about train timetables, train stations and their platforms.
How many train stations do you know?
I have 382 stations.
How many trains do you have?
I have 10,780 train trips.
How many platforms are there at Central?
Central Station has 22 platforms, 1 to 12 and 16 to 25.
Which platforms at Central go to Newcastle?
There are 2 platforms, 8 to 9.
What is the next train going from Central to Newcastle?
Arriving 13:15 at Central Station Platform 8, going to Newcastle Interchange Platform 3, arrival 16:09.
The app supports additional domains for arithmetic calculation, unit conversion, and its own identity and capability awareness. Computer, what is 10 squared multiplied by the sine of pi divided by 4?
The result is 70.711.
Computer, how many teaspoons make up a tablespoon?
The result is 3 teaspoons.
Computer, where are you hosted?
I am hosted on a system named Cyamo on the iPad platform, running Mac OS X.
So when the computer receives a request, it runs it through its response system, and if there was a positive response, that it normally cites it. Otherwise, it can add the applications discretion auto-generate a negative response. In its neutral simplicity, some of these auto-generated responses can be a little surprising. Let me ask, computer, what is love?
Love is a noun.
Computer, how do you know what to say?
Sorry, I am not cognizant of how I know what to say.
Again, all these replies are natural functional outcomes of how the SDK operates. The app also depicts the transcribed semantic in the form of a directed node graph here on the bottom. Let me switch to a screen capture and explain it a little bit better. This is the top of the app, and there are two text views. The top text view here has the recognized text that was recognized by speech recognition. The bottom text view has the reply together with the responding agent, the responder that was responding. There's a listen button and a speech cancel button. I'll be using a slide clicker actually to engage the listen cycle, so I don't have to use the mouse for that. The top half of the semantic node graph depicts the word tokens. So let me match these up. Where is mapped, sorry, that was a mistake. Where is mapped to the query determiner, the interrogative, and the R is mapped to the auxiliary verb token there, and U is mapped to the pronoun, and that's also identified. It goes through an identification process, and that was identified as the responder, which is the application on the part of it that actually responds. Going to the bottom hole, there's two sections. There is the legend, which depicts the actual structural levels of the semantic, and on the left is the actual semantic with a base node giving the transcription times. So that transcription time there was 4 milliseconds. Apple speech recognition performed in 280, and the semantic is depicted from the sentence up to its terminals in that node graph, which we'll go into later after we've discussed the actual structure of the semantic. This is the general content of the talk. There's a concept section where we talk about the semantic intent and response as in general as concepts. Then there is a section on theory where we go through the dictionary and how it functions, semantic representation, intent representation, a section on the technology facets associated with transcription. So there's how the transcription process operates, the response process that actually resolves a response, conversational nodes, which I'll describe what they are later. That is followed by a set of demonstrations on some devices, two Raspberry Pi devices, to show transcription operating on those. And then I finish with a set of benchmarks for CPU performance and memory footprint. This is a guide to the talk, and I'll be bringing this particular template slide up at various times to indicate where we are. We're going into concepts now, but I was worried that as this is probably new domain knowledge for you, you'd probably get lost within the meandering of the presentation. So I'll bring this up at particular talk segments to indicate where we actually are. In this segment, I will discuss the concepts behind semantic transcription. Now, first, I want to talk about sentence text encoding with respect to grammar, semantic, and intent. And each of these represent very different types of sentence encoding, each with having different developmental histories, different requirements, and expectations on what they are meant to provide. Grammar, for example, comes from a time when there was only a need to convey broad expression onto paper media. So it has historical origins, and it comes from a time there wasn't a need to be consistent or concise. And as it evolved around various locations of the populated world, it built up a lot of redundancy in the way it can be expressed, a lot of complexity, and at the same time, a lot of ambiguity. Where this over-complexity works for the human domain on the system level, it makes grammar very impractical. So the semantic, on the other hand, is an encoding of sentence text. It comes from the computing age, a more modern age, and so it has needs for conciseness, consistency, orthogonality and serializability. The semantic is still a representation of expression and meaning, but it tries to minimize things such as ambiguity as much as possible. In terms of derivation paths, the semantic is derived from grammar, and the intent is derived from the semantic. Intent in itself is more abstract than the other two. It doesn't have the specific structure like the other two have. The structure of the intent is more symbolic, being a programmatic representation and a representation of the interactions between the subjects and actions as given in the original semantic. It is synthesized specifically for a target application that we want to use the intent within, and so in a sense its life cycle is bound to the application life cycle. And it's generally, intent is generally not meant to be serializable, so its residence is generally bound to just that target application. In terms of fidelity of meaning, grammar and the semantic are meant to encode full fidelity, but the intent, on the other hand, is inherently lossy. It's lossy because it's meant to encode intent and so is agnostic to how the intent was framed or expressed. Of course, intent will still generally capture the content in the semantic through the use of subjects and actions, but they may have different representational forms within the intent. Ideally, intent is non-ambiguous, so it only refers to one interaction. And finally, I want to touch on the concepts of response expectation. So if this normally applies to polar questions. If I ask you, do you have the time? In a strict linguistic context, this is a request for an affirmation or denial, so a yes or a reply as to whether you have the time. But in a social context, it's really a request for time. So the semantic, being more of a linguistic creature, obeys the strict grammatical semantic linguistic response, and intent, being more of a social creature, obeys the social expectation. Now I want to talk about the actual logical units that grammar, semantic, and intent actually encode into. So grammar encodes into clauses and phrases, and within the clauses and phrases, the various grammar word types that you should be familiar with, except for possibly the determiner, which I'll outline more in the theory segment. Semantic, being more of a system functional expression, is encoded first within the framing, and that identifies how the sentence was framed, and so how the sentence is to be taken. And within the framing, a set of expression units which encode the content, being subjects and actions. Intent, on the other hand, as I said before, is more of a programmatic representation. It will probably include the content of subject and actions, but they may be represented in a very different form than the semantic. Framing and expression do map into the intent, but not in a one-to-one sense. The intent takes the framing and expression as interactions, and so it's agnostic as to how those interactions were framed or expressed. This is meant to be the semantic theory segment that covers the custom dictionary, the semantic and intent representations. But for the sake of brevity in this particular venue here, this segment will be replaced with a short discussion on word categorization. But of course, you can always go to the originware.com website at any time to view the full theory segment. And in the video, you'll see me outlining fully what the semantic representation is and giving a lot of walkthrough examples. But for now, I'm just going to go through a short discussion on word categorization. So any semantic transcription system will require some form of categorization scheme for its known words. And the OriginWare system uses a hierarchical URI scheme called the Word Reference Identifier, or WRI for short. And so here are some examples of WRIs. The bird parrot, for example, is categorized under noun, thing, animate, fauna, bird. Millisecond, on the other hand, is not a thing. It's a human construct, part of a measure system. So it's categorized under noun, system, temporal unit. Verbs are categorized under their verb types. And so generally the important thing to note is that the top level of the WRI indicates its grammar type, and the subcategories identify its role or type of word within that grammar type. I want to go over to the desktop and do some interrogation of word types. Computer, what is a parrot?
A parrot is an adjective.
Computer, what is a parrot?
A parrot is a bird.
And so if I look at the terminal for parrot, it's tagged with its WRI. We'll try some figures, some historical figures. Do you know Pythagoras?
Pythagoras is a historical figure.
And so there is a section in the WRI for the roles of people, and that includes professions, family relationships, fictional characters, celebrities, even cartoon characters, for example. I may try someone that the SDK doesn't know. Who is Kim Kardashian?
Sorry, I don't know who or what Kim Kardashian is.
And I might try something a little more vague. Do you know Santa Claus?
Santa Claus is a fictional character.
And while that is a very factual representation for Santa, it may not be fully socially appropriate. So what I'm going to do is put out a challenge for suggestions as to what Santa should be categorized under. So a suggestion for a socially appropriate category, and this challenge goes over the next month to the next CocoaHeads meeting, and you can email your suggestions to terry@originware.com, and please try to include some other figures or characters which will be included into your new category, and the winning Santa category will be disclosed on the originware.com website just before the next CocoaHeads meeting. While you may think that this is a nonsensical exercise, what is important here is not getting Santa into a slot, but having a broad functional categorization scheme in which words and nouns have obvious and natural residence. For you, it's an exercise in recognizing natural structural contours. So while the fictional role for Santa is a natural structural fit for a factual context of Santa, humanity overlays factuality with social appropriateness. And so this is an exercise in understanding the structural contours of socialization. So I'm going to leave that there now, and I'm going to go back to the regular intended talk segments. I'm now going to move on to the technology facets section of the presentation. So in it, I'll be talking about the transcription system and how it actually does transcribe, the response framework, how it resolves responses, and the conversational node framework. So the transcription parsing system. This is a macro level, a high level, macro level design of the transcription system. So there is an input and there is an output. The input is the sentence text, and the output are the vocal responses and the actions to be performed by the application in response to the sentence text. This is meant to be a pure design in the sense that it's decoupled from any implementation. It exists in its own design space, separated from code space, but is meant to be projected onto code space to yield an application or implementation. In terms of topology or element topology, this is a simple sequential compositional chain. There is only one element type. These are all operators. This design methodology is called reactive fabric, and it's actually meant to convey complex byway interactions within complex topological fabrics of various processing element types. And reactive fabric follows a design for interaction methodology. And in this particular design here, this is really just a simple one-way interaction between stateless operators. And so its projection on the code space should yield a single-threaded, pure functional implementation. Let's look at these operators. These all have an input and output data space. These four in orange are actually formal SDK operators, whereas the responder operator here is actually an application-dependent operator, and it's meant to resolve a response from the semantic. So it actually receives or has an input of a semantic and an output of the actual response set. So again, looking at these operators more in depth, the first to be used is the text tokenizer. So input data space, string, output data space, token sequence. It takes the input text, it breaks it up into words, tokenizes them into words, looks at each of the words up in the dictionary to get the collective WRIs associated with that word, packages those individual tokens up into a sequence, and passes them over to the token canonicalizer. So the canonicalizer, input data space tokens, output data space token sequence, it performs corrections and optimizations on the token sequence and passes that over to the grammar parser. So input data space token sequence, output data space grammar topic tree. The grammar parser parses a token sequence into a topic tree that represents the grammar, but that grammar tree also includes the subject and action. So that gets parsed over to the semantic parser. Input data space grammar topic tree, output data space semantic. It synthesizes the framing and the expressions from the grammar tree and includes the subject and actions that were derived in the previous steps, packages it up into the semantic and sends it over to the responder for responses. So typically, these individual operators here will be projected into CodeSpace as a separate class. These notifications would typically be structs. And so the action of parsing these notifications over is really just a simple method call on the class with a parameter which includes the tokens, the notification. So this is really a very simple, efficient design. But it's not only a functional design, there's actually embedded within this a performance design, in the sense that each of these operators are meant to fit into a 32K L1 cache. So that's a separate data instruction case. And so, for example, the text tokenizer actually fits into a 32K cache. It performs its intensive operation very efficiently within a 32K cache, parses its results over to the next operator, which again fits into a 32K cache and efficiently performs that, and so forth. So in the end, this whole expression here exhibits a cache, L1 cache read miss rate of less than 1% and a forced write back of less than 2%, and this provides for an extraordinary level of performance. 16K L1 caches are also tested, and those figures, those cache read miss rates went up to between 10 and 20%. So a 32K L1 cache CPU is a recommended device or higher. 16K is usable, but it is not recommended. We can now go on through an example transcription process. So the sentence is, "Where is my coconut?" Tokenization separates out to individual words. It looks up the individual WRIs, packages each of these up into separate tokens. So it includes the word text together with the WRI, forms a sequence and parses it over the canonicalizer. But in this case, the canonicalizer doesn't do any alterations, so it really just goes to the grammar parser. That forms a grammar tree which includes the actions of is and my coconut. Passes that over to the semantic parser, which determines the framing of an identified framing of an interrogative where, with a directed action expression, and within that expression a directed subject of my coconut and with an action of is. And then that goes over to the responder. Moving over to the next technology, Facet, response framework, which is responsible for resolving a response. So response resolution is really just as important as transcription, and that is because the response system can expand exponentially as use cases build up. So the OriginWare response framework separates or delineates individual knowledge and capability domains, and it delineates those into separate knowledge and capability responder trees. So the trees delineate boundaries between knowledge and capability domains, and then the nodes within these trees delineate separate aspects of those domains. There is a semantic router that actually routes to those trees to determine the response. So when it receives a query, it actually runs the semantic through the individual trees that it does have to come to some response. But generalizing a little more specifically, there's an application response coordinator that routes the semantic to the semantic router, which then in turn routes them through the individual trees and then responds back to the response coordinator. Going on to talk about the actual type of responses that come back from the trees, there are 4 types of responses. There could be a positive response. So there was a relevant responder tree for that knowledge domain that was able to form a positive match and responded back with a positive response. Or possibly a relevant responder tree for that domain considered the request to be invalid or inappropriate in some way and decided to give a negative response back. Then there can be a hard failure, typically indicative of a parser failure or invalid grammar, for example. And finally, there's a possibility that a responder tree can give no response back. So going back to our previous slide here, if there was a positive response, then that would typically be forwarded straight back to the coordinator. If there were only negative requests, then the router would forward those collectively back up to the coordinator, and they would decide to respond back with one of those negative responses. If all these responses back were nils, then the router would reply back to the coordinator with a nil response, and then the coordinator has the option of auto-generating a negative response. Going on to the next technology facet, conversational nodes. So this is an extension of the concept of human to system vocal interaction or conversation, and going to system vocal interaction or conversational interaction. So there's a forward textual request, which represents a vocal request in text, and then a response back between 2 system conversational nodes. This is a typical application of conversational nodes. So typically there's a mobile device with a conversational node that actually wants to converse with an appliance, an instrument, or an IoT device with a conversational node. So typically the app will have voice recognition to encode a request. That request is then routed to the appliance. It runs it through its conversational responder tree set, performs transcription, then runs it through its responder tree set, forms a response, and responds back. And then the app performs voice synthesis in its reply back. But an extra component is needed here. Some form of discovery is required, and that's typically Multicast DNS Discovery, which goes by various other names such as Bonjour or ZeroConf. So the appliance advertises itself on the local subnet, and then the mobile device app performs DNS discovery to get the IP address of the device or devices. And once it has that, it can converse. And the conversational protocol normally is HTTP, so a RESTful protocol is quite adequate. The vocal text is given in the body of the HTTP request, and then a response back is given back in the body of the HTTP response, plus some very simple metadata, which includes the type of response, so whether it was a positive, negative, or failure, and so forth. This can also be used in an edge-based scheme. So a client app conversing with an appliance or IoT device can converse, but perhaps the appliance can't, its domain tree cannot cover that request. So it can refer that request to a cloud edge conversational node, which will reply back, and then the appliance can reply back to that. So this delineates responsibility of response resolution, so that the appliance only needs to cover those responder trees that are appropriate for its own management of its appliance. And if there's a out of scope request, it can refer that up to a higher level for response resolution. And that could typically, for example, be assistance with the device, maybe a support request for the device, those type of things. And of course, the client app can also refer upwards to a cloud edge if it is aware of that cloud edge node. And of course, all this is can be done through HTTP.
Cool. Thanks for that, Terry. So now I'm going to flick over to Tom's. Oh, sorry, before that. So just so you know, Terry's talk will continue with a part 2 next month. I'm now going to flick over to Tom's talk. And just a quick apology for that last one that had the progress bar visible throughout the whole presentation. I'm not sure why, and I did try to get rid of it, but it didn't want to go. So hopefully it doesn't happen with Tom's, but we'll try again now. So let's get started.
Hi everyone, today I'm going to give a short talk about the Fetchable Protocol, which is part of an open source library called BFW Fetch. The first question you're probably asking is why? Having built many apps, they all tend to make API calls, and you end up with a lot of boilerplate code where different developers on different features, or the same developer on different features, can tend to duplicate a lot of API call code between different view models or view controllers, whatever you're using. And because the parameters within that code are slightly different, it's not technically duplicate as a whole, but it's very bad architecture. And there are other frameworks, but I find that they're quite complex or too big to dive into when you need to make a change. And now that we have Combine, a lot of the work is already done for us, and a lot of those other frameworks tend to reinvent what is now a new wheel. So thus, Fetchable was born. It's very sort of lightweight and answers all of those needs for us. In order to use Fetchable, all you've got to do is provide a type, and at a minimum, it has to provide the base URL as a static var, fetch keys as an enum called key, and the fetched type. That is, you need to tell it what type to expect from the response. And Fetchable is pretty smart. It will figure out everything else. It will figure out the rest, pun intended. It'll figure out the REST call using Combine. It will figure out the request parameters from the keys. And depending on what you tell it to do with those keys, it will use it either in the headers or in the get URL, wherever it's needed. And it will even figure out the end URL path, so that if your type, as you'll see in a minute, is called weather, then it will assume that the end URL path is called weather. And you can override all of these. So speaking of weather, let's have a look at open weather. This is probably one of the typical coding exercises that is given to potential new employees in a team. It's good because it's fairly extensive, it's open, and you can just get an API key just by going onto the website. So there are many endpoints with open weather, but I'm just going to have a look at one, which is the endpoint called weather. And to use that, we need to provide the 3 things that I just mentioned earlier. So this is a requirement of the open weather API. that we use the base URL, as you can see there, api.openweather, etc. That this particular endpoint, we want to use the end URL path of weather, so it will be that base URL / weather, and various parameter value pairs, key value pairs. So let's have a look at the key value pairs. So there are quite a few, but let's just focus on these three. So the first one is the app ID, which you get just by registering on the OpenWeather website, and they give you a key. And then a curious key called Q, which is actually for the site, such as Sydney, AU would give you Sydney, Australia, and another key called units, which is metric or imperial. And so if we were to use Fetchable to create a weather type to interface with that API, this is all we need to do. We just import BFW fetch. We create a struct called weather. We declare that it's fetchable, and then the compiler will say, well, in order to be fetchable, you need to provide the base URL, the enum key, and the fetched type. So we might fill it in like this, just based on what we were looking at a minute ago. So the base URL, the keys of app ID, Q, and units, and the fetch type, which we'll define as site, because when you ask for the weather for Sydney, it gives you back all of the details in a JSON called site, which we'll look at in a minute. But if we have a look closely at this, I've named the keys exactly the same as the API requires, which is fine for the API, but they're not very Swifty. Q and units aren't good Swift names. Q doesn't tell us what it is. It doesn't tell us that it's a site. And units, generally, when naming variables in Swift, we use a plural for an array. So let's replace those with Swifty names. So let's use site and system. And fortunately, the fetch key will use the raw value of the keys, which I've put here as Q and units, when it's actually making the API call. Very similar to coding, the way coding keys works when you're decoding or coding for JSON. So that's how we set up the fetchable type. And then all that's left is to initiate the fetch. And to initiate the fetch, we simply ask our fetchable type for a publisher and give it the key values with each of the values that we want to use for that particular fetch. So here I'm sending a fictitious API key, it's fictitious app ID, and the site of Sydney, Australia, and I'm setting the system to metric. And part of the advantage of having these as enum cases, these keys, rather than just strings, is that the compiler will enforce those instances in the dictionary to the point where when you type, it gives you a list of what it knows to be valid keys for the key values. So that's another point of failure and debugging that disappears. So that's how you fetch. We've created our fetchable type. We've now got a publisher from that type. And if we fire that off, it will give us back a publisher with the response. And that's all there is to it. So thank you for watching my talk. I told you it'd be short. Okay, it's a little too short. So let's have a look at some more detail. But what I've shown so far is all that you need to make it work. With each of the fetched key value pairs, I was showing the values as strings. Now, it can take a string, an int, or a bool, or any other type that conforms to fetch value. And you can make your own types that conform to fetch value. All you have to do is provide an API string, which will default to be just the description, but you can use any sort of mechanism that you want. But here's a simple one. I've just created an enum called system for the whether it's going to be the metric system or the imperial system. And that means that I can use that instance as one of those cases rather than having a string, which I could get wrong. And the publisher output, so what you actually get back from the weather.publisher is an any publisher with your fetched type or an error. And you remember that the fetch type was declared as part of our fetchable conformance here when we created the weather type. And then we defined fetched as being site, which we'll look at in a minute. And we probably want to make a custom publisher. So this one works fine, but we're going to supply this API app ID over and over again. And we probably want to break up the site into a Sydney and country code. And we might want to otherwise manipulate our keys from the input of a custom function. So a custom function might look something like this. So this is just another publisher that calls the built-in publisher, but you can see that the parameters of city and country code have default, where country code has a default value of nil. So if you just type in Sydney, the API will cope with that. And the system defaults to nil. And again, the API has a default, which I think is metric. And the site that is sent to the API has the city and country code appended, and it removes any nil. So if the country code is nil, it will just be the city. So compact net map takes care of that, and the joined separator puts a comma between. So this makes a much nicer custom publisher, more sort of Swift function, and gives us a nice, simple Swift interface. And then we can call it very simply. So we can call it as weather.publisher City of Sydney, weather.publisher City of Melbourne with the country code of Australia, and we can optionally specify the unit system, whether it's imperial or metric. So how does this look in an app? Let's sort of be a bit more real and see how this might look. So if I was making a weather app, which coincidentally is the demo app that's provided in the BFW fetch framework, then I might create a weather scene that looks something like this, where it takes input from the UI, the city and country code, and uses a picker style. There's a segmented picker style. So they're all our UI elements, and you can see there I've got a view model, and the view model is where I'm going to store my city, country code, and system. And then the view model might look something like this. So you can see I've got city, country code, and system for the input, and I've got site for the output. And because I'm using combine, I'm going to have a set of subscribers. And whenever someone hits the fetch button after typing in the fields, then it's going to call my custom weather publisher with the city, the country code straight from the text fields, and the system straight from the segmented control. And this is pretty standard. I'm not doing any error handling here, just for the sake of simplicity. And again, that's it. So the view model's done, the scene's done. What I haven't spoken about is the fetched type. So remember that we defined fetch type as being the site. And what I'm about to show you has nothing to do with fetchable. You would have to do this whenever you're decoding the response from an API. But if your fetch type is decodable, then fetchable will decode it in the publisher output. So you'll remember that in our fetchable weather, we define the fetch type as being site. And as long as we define site as being decodable, then the publisher we get back from fetchable will have that all nicely decoded for us. So looking at the weather, Open Weather API, the typical response looks something like this. I've simplified it a little bit, but it's nested with an ID and name of the site and the weather for that site, and then a main grouping of the different temperatures. And if we converted that as is to Swift, then it would look something like this, where I've just used exactly the same names and the structure to mimic the JSON structure, and Therefore, I don't have to write any custom decoders or anything like that. I could just declare this as decodable and it will work. But again, this has nothing to do with fetchable per se. This is just good practice for decoding output from a JSON API response. These particular names here aren't good Swift names. So you can see weather is actually an array of weathers. So it should actually be called weathers or weather array, not a singular weather. And these abbreviations of temp would be better as temperature. That's arguable. But feels like and temp min and so on, they should all have temperature as the suffix. So again, we would name them to be Swift-like and use decodable coding keys to provide the raw values that correspond to the API. All this is optional. This is just sort of good practice. It's not part of Fetchable. And then our UI, based on the weather scene that we're looking at before in Swift UI, if we fetched and then created a UI for our site, it might look something like this, but I'm not going to code for that because there's nothing to do with the topic. And there's a lot of other things that you can override in Fetchable, but that's the basics of it. It works very well. As I said, it's very lightweight. It uses combine and standard sort of Apple technologies under the hood, but it takes care of all of the URL sessions and error handling and mapping of keys and so on. It's open source. You can find it on Bitbucket. Thank you to our sponsors, and on GitHub. And there's also an article that was published this week in Better Programming that goes through pretty close to what I've just presented, but it's a bit easier to read and re-refer sometimes. So if you just look up betterprogramming.pub, you should find it there. If you have any questions, then you can chat me now in Slack, in the Sydney CocoaHeads Slack group, or you can email me, or I think there's a video session after the meeting. Thanks a lot for listening, watching, and I'll catch you in the things. Bye.
Cool. Thanks heaps for that, Tom. Just stop sharing the screen. All right, so thanks for joining, everyone. That concludes the April 2021 CocoaHeads. Also, a big shout out and thanks to Tom for presenting 3 months in a row. That's not easy, but we really appreciate that. As mentioned earlier, hope to see you next month, hopefully in person. I'll post details about that in the Slack as soon as I have them. But otherwise, catch you all next month. Stay safe. And there will be a post-Zoom catch-up happening. I'll post a link to that in the Slack group in a few moments. So see you all.